In their favour, ground source heat pumps generate less CO2 than conventional heating systems, hence why they're considered to be a renewable energy and qualify for government funding under renewable energy schemes. But you do need electricity to power the pump, which circulates the liquid in the ground loop. But for every unit of electricity used by the pump, you get between 2 to 4 units of heat, making it a very efficient way to heat a building. So typically you'll see a little graphic like this associated with heat pump technology. So basically there's your electrical power going in, so 1 kilowatt, and your low temperature renewable heat energy recovered from the environment. So that's either from your ground source, from your air source, or from your water source heat pump. So you have 1 kilowatt that you provide as electricity, 2 kilowatts is extracted from the environment, and then you get 3 kilowatts high temperature heat output. So that's generally where the coefficient of performance comes from for calculation for a heat pump. So you can see down here COP, coefficient of performance. And basically what the coefficient of performance is a measure of how much energy are you getting out over how much you actually put in. So in this case you're getting 3 kilowatts out, you're only putting in 1 kilowatt energy, and you're extracting the other 2, but you're only putting in 1, so you're using 1 to get 3, so this has a coefficient of performance of 3, so it multiplies it by 3 times. So you have a look at the little plot at the bottom here. It shows you the coefficient of performance for this green heat pump G15, and basically this one works on the outside air temperature, so it's an air source heat pump. So you can see that the coefficient of performance, minimum and maximum lines here. So an air source heat pump can work at a COP of 3 down to about minus 10 degrees in this case here. Whereas when the outside air temperature is 10, 20 degrees C, you're up in the sort of 4 to 5 COP output regime. In addition, you can also use cheaper economy 7 electricity tariffs to run the heat pump at the evening time to use the lower cost electricity to power the heat pump. And special heat pump tariffs are sometimes available from some electricity suppliers when you install one of these devices. And if you lived in a suitable area, you could also consider PV panels or a wind turbine for a greener, cheaper source of electricity to drive your heat pump. Main benefits of ground source heat pumps: they could lower your fuel bills, especially if you're replacing conventional electrical heating. They could provide you with an income through the government's renewable heat incentive scheme. They can lower your home's carbon emissions depending on which type of fuel you're replacing. You don't need fuel deliveries because they just run off electricity supplied to your house. They can heat your home and also provide your domestic hot water. And basically they need very little maintenance. They're essentially a fit and forget technology. But unlike gas and oil boilers, heat pumps deliver heat at a lower temperature over much longer periods. So during winter time, they may need to be on constantly in order to heat your home sufficiently. And when a heat pump is used, you also notice that radiators don't feel as hot to the touch as they might do when you're using a gas or oil boiler. And that's basically because gas and oil boilers run at a nominal temperature of 65 degrees C into radiators, whereas a heat pump will be running somewhere in the region of 45 to 50. So generally you need low temperature specific radiators for combining with a heat pump system. The drawbacks of a heat pump system: a ground source heat pump is quite expensive, and depending on the size of the system that you go for, the cost to install one can range anywhere from £9,000 to £17,000, and that doesn't include the cost of fitting underfloor heating if you want to do that as well, or low temperature radiators. Energy Saving Trust estimates a typical ground source heat pump could save you about £180 if you replace an oil fired heating system, to £480 per year if you're replacing an electrical heating system. But in the trials that the Energy Saving Trust run, only some of the heat pumps actually ended up in clients having reduced heating bills, and that was basically down to issues with the systems not being correctly sized. Ground source heat pumps generally not suitable for properties that exist or have existing gas-fired central heating, as The technology works at lower temperatures, making it better suited to homes with underfloor heating. The groundworks required to dig the trenches for ground source heat pumps can be disruptive, and also planning permission may be required if space is at a minimum and you actually need to put a borehole in. Ground source heat pumps tend to be better suited to new build homes as well, as they basically can be put in as part of the construction process as it's ongoing. A drawback of a heat pump is that you still need electricity to drive the heat pump. So in essence, a ground source heat pump can't really be considered completely zero carbon unless the electricity used to drive the heat pump is used from a renewable source such as a solar PV or a wind turbine. And ground source heat pumps are generally only recommended for newly constructed houses with insulation and air tightness that meet the latest building regulations.